My name is Kunal Anand, and today we're going to be talking about language theoretics and runtime application security. So a little bit about me before we go into the agenda. I'm the co-founder and CTO of a company called Brevity. We're building a runtime security technology, and I have security and engineering experience leading teams and starting programs at fun places like NASA, MySpace, so getting to clean up after the Sammy worm was a really fun and interesting set of experiences, and I'll be delighted to share some of those anecdotes. And prior to starting Brevity with my co-founder, was at the BBC Worldwide, doing digital entertainment and gaming. I know when people think of the BBC, they think of Doctor Who and Top Gear. They don't think about games, and that was a separate thing. And I've done a lot of these OWASP talks, and super delighted to be here at AppSec. I've always wanted to come to AppSecUSA, so it's great to come here and talk about language security. So what we're going to talk about today is the current methodologies, what we're using across our cybersecurity defenses for protecting against OWASP-related attacks like cross-site scripting and SQLi. We'll go into some practical applications, and then I'm actually going to take you through a code walkthrough. So hopefully the demo gods are on our side, and we're going to be able to compile and run some tests. I think it's going to be pretty interactive to go through and add more use cases to our current LangSec implementation. And then we'll talk about how you can get involved with language security and different things that you can do for the entire community. So for those that attended my 11 a.m. talk, a lightning talk or 10-minute talk, some of these initial slides may look a little similar. They are. And so this is meant to catch everyone else up, and then we'll deviate and we'll go off-roading into some code examples. So when we think of cybersecurity and cybersecurity defenses, we're primarily thinking about technologies that are being used in network and edge components like firewalls or web application firewalls. We're also thinking about things like runtime security. So you've heard the term RASP. Those are two interesting approaches that are related to defense and application-specific defense. Now, there's static signatures, there's dynamic signatures. The former is related to string replacements, while the latter is related to regular expressions. And effectively, they can take the form of whitelists and blacklists. And we'll talk about my anecdotes at MySpace and having to build a lot of those up over time. And then you've got behavioral as well as statistical analyses. And they require you to build a normative understanding of what is good or quote unquote normal behavior for your applications. And you can do it on an application basis, or you can go on a per user basis per application. And so these are the different methodologies that we see today. You can think about the first two as effectively playing a cat and mouse game with your attackers. You build up signatures and they build up a bypass, and they'll use conventional and relatively non-conventional tools like fuzzers, some open source, some homegrown. And then you can think about the latter as interesting, but also having some limitations, especially if you practice things like continuous integration or continuous deployment, where your applications are effectively changing all the time. It's really hard to build normal behavior or define normative behavior when things are changing all the time. So when it comes to signatures in a lot of defense systems, we see a lot of usage to protect against attacks like XSS and SQLi. In the case of XSS, a trivial example being a JavaScript tag with an alert. And for something like SQLi, you can see the tautology in this particular case, basically segmenting the current condition, introducing an or and a statement of truth, or a tautology, a 1 = 1 in this case. So this is an example, cross-site scripting, regular expression. I took this from an open source project. I have absolutely no idea what this does. Odds are, upon further glance, you probably don't either. But if you run a lot of perimeter-based defenses, you probably have something like this. And not just this, but you probably have dozens of these things. I'm seeing head nodding, so yes, everyone agrees. But it's not too hard to circumvent something like this. One of my favorite tools is this open source thing called JJ Encode, and you can turn something like an alert 1 into that. So if I'm building a regular expression to try and look for alert 1, I can turn something into this spaghetti, and now what? You now have to build a signature or a definition for this. And this isn't even a palindrome. And JJ Encode gives you that ability too. So let's say if I wanted to make it even more complex, I could turn it into a palindrome if I really wanted to. And this is the kind of extent that you typically see with people playing a signature-based model. You evolve, you build a control, and then they bypass the controls, and they being quote-unquote adversaries, or people just looking to bypass a control. Could be researchers. I've been here. I joined MySpace about 6 months after the Sammy worm. And when I joined the company, they had built their entire cybersecurity and application defense system purely using regular expressions. And it wasn't just one, it wasn't 100, it was thousands of regular expressions. Thousands of regular expressions that would run across every input variable for every HTTP request. So who here has used MySpace? Show of hands. You guys probably remember that a long time ago, MySpace used to have a profile section. And in the profile section, they had about 20 different inputs. So you could put in your name, your favorite movies, and all of those variables would get submitted as part of one giant form post. And 20 different variables coming in would run through thousands of regular expressions each. Think about how bad that is in terms of CPU and in performance. And every time the attackers found a way to bypass every one of our controls, we'd have to go back in and introduce another regular expression. So you can imagine just how massive this library of regular expressions became, and rather fast. So I want to shift gears and talk now about database regular expressions, and our code demo will dive deeper into SQL injection. Look, we are all AppSec practitioners. We all want developers to do the right thing, which is use parameterized SQL. I think everyone knows that. But there are a lot of applications that simply can't. And it could be legacy applications. It could be applications developed by a third party. It could be in closed source applications altogether. And for whatever reason, a lot of folks have thought for years that you can apply regular expressions to understand or detect for SQL injection inside your database queries. There's a little bit of a fallacy here, and I'll show you what I mean by that. And what I mean fallacy and how that relates to regular expressions, I'm purely talking about static comparisons, dynamic comparisons, tautologies, as well as contradictions. So let's take the tautology example, all the way to the far left. So something as simple as an or 1 equals 1. I think we all know that that's going to go in and short circuit or allow the query to fetch everything upon that statement of truth. But that second one is also a valid tautology, where 2 equals 1 plus 1. And my favorite one on the far right, trigonometric functionality, sine of 1 equals cosine of 0. Right? This is not a trig class, or we're not going to dive deep into geometry or trig, but it's just meant to illustrate that there are numerous ways you can create a tautology inside of a SQL query. It doesn't have to be 1 equals 1. The problem is because there's an infinite number of ways to express this, that means you have to have an infinite number of regular expressions to protect against this. So we need something better, right? You understand that regular expressions and signatures can only take us so far. We have to understand the payload. We have to try and understand how something is going to execute before it actually does. And we need to do it very quickly. Because if we're looking at something like a SQL query from within the context of an application, we have to be really fast. So this is where LangSec comes into play. So I can't take credit for coining this term. This term was created in 2005 by Meredith Patterson at Black Hat. So more than a decade ago, Meredith talked about the merits of language theoretic security. That's what LangSec stands for. And the idea of LangSec is to fundamentally look at input through the lens of its language. And if you take that down, all computation, whether it's a SQL query or a cross-site scripting attack, takes the form or is expressed by a language. Could be SQL, it could be Oracle SQL or PLSQL. It could be HTML or CSS. The fundamental idea is to build a grammar of that language and then make sure that when you're accepting an input or evaluating an input, you evaluate it within the context of that grammar. And that then allows you to see what is going to theoretically happen, but then you can transform, you can evaluate, you can do all sorts of novel things. So LangSec is great for I/O applications. And I don't know if Meredith was thinking about web applications specifically when she was making her Black Hat talk, or giving her Black Hat talk rather, but if you think about it, for I/O applications like web applications, LangSec actually makes a lot of sense. And we'll talk about a runtime example in a little bit. But when you think about web application I/O, and for those that are functional programmers, you've probably heard the term side effects related to input and output. And when you think about web app I/O, you're dealing with things at the HTTP layer, at the database layer, and at the operating system, specifically where the app meets the operating system. So when it comes to something like cross-site scripting, it's very common for us to see things being dropped into query parameters or into post bodies or request bodies. It's also common for SQLi to be inside of a database query. And for an operating system command, we can see usage like calling a different program or chaining different commands together using the pipe operator. From a high level, this is what LangSec computation looks like. The first phase is lexing, where you build up a series of tokens. So specifically, if there's a string that comes in that says hello world, each one of the characters will be a token, HELLO. And you can then do a compaction upon that, so hello becomes a word, and that's also a valid token. Ultimately, you build up this tree of tokens, and then you can use a parser to verify that the tree is in fact well-formed, or what's called semantically correct. And that allows you right away to go ahead and discard anything that doesn't conform to the grammar. So if you're using a SQLi grammar, and you've got something coming in that looks like HTML, it would just be invalid SQL, right? We know that, but using a parser to verify the semantic correctness, you can quickly reject something. Then you've got these last two. One is around evaluation, and we'll talk about evaluation, and we'll show you a demo of actually doing evaluation to look for tautologies. And then you've got transformation. So let's say you evaluate something to be a static tautology or a static comparison that contains a tautology. You can then transform it. So if you wanted to, you could altogether remove the tautology. You could augment the tree in an arbitrary number of ways. So there's a lot of tools out there to build lexers and parsers. So there's plenty of open source technologies. You'll notice that there's one in particular that is showing up on this list as both a lexer and a parser, and that's Antler. And in this demo, we'll actually walk through an Antler example. We'll build an Antler grammar, and we'll modify it, and we'll put it inside of an application, and we'll see what we can do with it. Now, you can always roll your own. Now, the problem with rolling your own, and again, I'm a sucker for not invented here. The problem with rolling your own is if you don't define your target language or know the use case of exactly what you're looking for, you can scope creep yourself really fast. And you can end up in a situation where what should be a relatively small project can end up taking months or possibly years. And I've fallen into that trap before. Unfortunately, there are a lot of technologies and tool chains out there that allow you to jumpstart and get started really quickly. And again, your use case may in fact vary. So in terms of our code and walkthrough that we're going to go through, I'm going to walk through an example called KSQL. And it's a minimalist SQL language. So it allows you to do arbitrary selects. And I'll show you the language examples in a minute. And we're going to use Antler to generate our lexer and parser. And it's all going to be based on the custom KSQL grammar. We're going to use Java, specifically the latest version of Java 1.8, point whatever patch is installed on this computer. And we're going to use JUnit for testing. And it's important that we use JUnit, and I'll show you in a minute why. So KSQL is an intentionally simplified grammar. It's not really a production-ready SQL. I wanted to come up with an example that would be useful for this demo. And so specifically designed a SQL variant that's very limited in terms of what you can do. And it's a subset of the SQL specification. And when I say subset, that's probably giving it a lot of credit. It's really just one statement. And it allows simple selects with numeric conditions from a target database. This source code that I'm going to show you is completely open source. The final example that we're going to walk through today is fully available on my GitHub. And we'll talk about lots of expansion opportunities and things you can do. For those that are inclined to type and be in conferences, if you want, feel free to jump on in, grab the source. You can follow along on your own laptop if you want. And I'll show you the link at the end in case you're curious or if this piqued your interest. So when it comes to intentionally simple queries, these are the primitive examples. So select star from users. Select username and password from users. So the first case is a wildcard. The second case, you actually specify columns. And in the third case, we have conditions. So being able to specify something in your where. And in this particular case, it's a dynamic comparison. A column is equal to a literal. And in this case, our literals we've defined as integers. So why Antler? Well, for this particular example and for this talk, I wanted to use something that would generate a lexer and a parser at the same time. And I also wanted a tool that would allow me to do data visualizations live. So one thing that we'll do is we will throw some example queries at the grammar that we've generated, and we'll visualize the tree. And that visualization, I hope, will enforce your thinking of what langsec is. So by the time we get into source implementation, it'll make sense where we're pulling all this information from, or what you can do with something like a lexer and a parser. You can always learn more from antler.org. Terrence Part, the guy who created Antler, he is incredibly active on mailing lists, incredibly active on GitHub. So if you find optimizations, things you want to do, you can always jump in. And Antler is widely used in a lot of different systems across a lot of different companies. I've heard of implementations at Google. I've heard of implementations at Facebook. Our friends here in the front row were talking about Antler with me a little bit ago. And there are lots of interesting applications. And you're not just limited to Java either with Antler. You can generate your target output in C#. There are Go bindings as of this summer, and there's also Python as well. So when it comes to defining a grammar, you really want to start at the root, the highest possible level. And you want to define all your sub-expressions. So for something like select, you have select, some column names, where, or from, sorry, table name, and where, some list of conditions. Now, all of those things are a mixture of expressions and literal values. And ultimately, your expressions distill down into a chain of literal values. And Antler ships with a really nice tool that allows you to run your grammar through the Antler toolchain, and that generates Java code, and then you can use your standard Java toolchain like Java-C to compile that code, which could then be used inside of your application. So let's take a look at the grammar for KSQL. And we'll actually modify the grammar live so we can add a new statement type. So again, KSQL is very, very limited. It only has support for selects. Let's go in and add delete as an option. So I'll do my best to increase the screen size. So let's take a quick tour of the grammar so far before we get into modifying it. So in Antler, you define a grammar or you provide a name for your grammar, and in this case, it's KSQL. This is the root expression. This is where everything distills and actually everything funnels in from. And you can see right now it only has one rule for select expression. And in select expression, we've defined select column list from table name where expression. Now, these uppercase values are literals. And you can see the literals defined down here. So you'll notice that they have quotation marks because these are literal strings that we want to match. These are literal strings that we want to capture. So in this case, you'll have also noticed that we have an uppercase variant and a lowercase variant because when you build a lexer and a parser, it's rather specific. And so if you wanted to allow queries to be in uppercase or the word select to be in uppercase, you actually have to define it. Now, this doesn't support mixed cases at all. And if you wanted to support mixed cases, the common approach would be to build literals for every single letter. And every single letter would have a pipe. So A would be uppercase A or lowercase a. And then you would chain all of the literals together. So that is a common approach that people have gone to for supporting mixed cases. So these are the expressions that we have here. So looking at column list, we've got an expression in here to look for a wildcard. And if I go down here, wildcard relates to star. And we've defined star as a literal value. So again, all of this is open and publicly available. So I won't spend too much time on the bottom stuff other than just saying that this over here is an identifier. And for those that have built and used regular expressions before, this might look a little similar. Effectively, we're defining a range of characters that we want to allow. And again, uppercase or lowercase. And we've defined our integer as something 0 through 9. Again, if you've built regular expressions before, I think a lot of this might look similar. And then down here for punctuation, we're just saying to skip over all the punctuation. That includes white space, so spaces, tabs, new lines, and then also semicolons as well as commas, because we don't need to worry about that. In our parse tree, and at least for this use case, we don't care specifically about that. We care about static comparisons, dynamic comparisons, the table information, the select type. So if we wanted to go in and add support for delete expressions, we would just start at the root node. So I'm going to go in and add delete expression at the top, and now I'm going to implement it. So delete is going to be delete from table name. And we also want to go in and capture the trailing semicolon, because again, it's possible for us to have a semicolon, but it's not required, hence the question mark after that particular grouping. So we've defined delete from table, but we don't have the literal value for delete. So that means we now need to go back down here and add support for delete. And in the crude hack that is KSQL, that doesn't support mixed casing, we'll just do that. Okay. So I'd mentioned that Antler ships with a really nice visualization tool. I'll actually show it to you now. So it's on the command line. You can type in a command like this. So this is similar to what you saw on the slide before. At the top, we're going to call Antler on the grammar. We're going to call javac to compile the Java source. And then you'll notice this additional command. This is going to actually run the grammar through a visualization tool and specifically look at starting at the top level node, expression. And if you recall, that's the choke point for everything. That's where we deviate between delete statements as well as select statements. So let's go in, we'll run it. And so you think that you would see a pop-up, but no, this is actually totally valid, because now we can go in and we can type in a query to do a live demo. So if we type in something like select star from users, and I hit Command D at the end, we'll generate a tree. And so I'll jump in here, I'll expand that up a little bit, so you can see what we're able to see from the perspective of the grammar, at least what the input looks like. So it's a select, and you know that because it's the top level expression. Star is a wildcard, so we're linking these two things together. And table name is related to users. So without having to define patterns, signatures, we're able to extract all this information in a tree like this. So if we go back and we try that delete statement that we just implemented, delete from users, run that, and there it is, delete from table name users. So we just added very naive support for delete statements, and obviously the SQL grammar for things like MySQL, Oracle, or SQL Server are far more dense. But for KSQL, I think this provides us with enough visibility for what we care about and what we need. And if I wanted to hone in on specifically comparisons, like for instance, tautologies, I could do that here. So let's say I wanted to pull out select username from users, where 1 equals 1. Close that off. And I'll open this thing. There you go. So it's a select expression. In this particular case, it's not a wildcard. We actually get a list of columns, get our users as the table name. And then you'll notice this is something new, this where expression. And in this particular case, we're observing a static comparison, a 1 equals 1. So that's a very high level look at what designing a grammar looks like, and also a high level look at how you can visualize what a grammar or what your grammar or how your grammar will behave. And it's really, really helpful for testing. I can't tell you how much and how nice it is to have something like Antler that gives you this out of the box. So you can build a grammar and you can rinse and repeat with testing new kinds of rules, new kinds of expressions, trying different kinds of tokens. But now let's go into something cooler, which is we've built this tree, we've compiled this Java output. Now let's try and use this. So as you saw, we use Java C, so we can actually compile Java, and you actually get Java source out of something like Antler. We can actually go in and use the generated parser for security. And if we wanted to, we can iterate programmatically through the tree that we generated via Antler to observe what's going on. And if we wanted to, we could even modify all of that. Now, I mentioned tautology. Tautologies are effectively statements of truth. And in the case of KSQL, we're specifically looking at integers and looking at comparing integer values. There could be all kinds of other tautologies that you saw before. So mathematical tautologies, trigonometric tautologies, even doing things like string concatenation or string replacement. And for KSQL, we'll focus purely on integer equality to keep things pretty simple. Now, I want to talk a little bit about testing, because testing is incredibly important if you're going to take the path of langsec. So for this, what I wanted to do, and you'll see it in the demo, is not just build a giant programming application and walk you through the lines of how the application is constructed, but instead actually start with the test cases. And the reason for it is, I'm a firm believer that unit testing, especially when you're building a grammar, is important to catch edge cases. But specifically, it's useful for determining whether or not the generated parser is doing what it should be, and also that the internal logic that you might design from a security perspective, let's say to reject a query or to evaluate a query, is in fact correct. So let's hop in to this Java example. So you'll notice something simple like a Java main. This is the entry point for a traditional Java application. We're not going to focus any time on this, because this is not really what's of importance. What's important for us is these unit tests. So specifically, if we wanted to verify that our parser was behaving correctly. So in this particular case, testing a wildcard query. And I built a little class called intelligence. We'll deep dive through that in a second, with a method called build. You pass in a string of SQL, and you get back an intelligence object. And the intelligence object has several fields. I'll go to the top. For instance, the statement type, the table, a list of columns, and if it's a dynamic comparison, the column name, the value that's being used, the static values. Again, we're using a trivial example here of comparing two integers, so we can hold both of these. You'll notice that these aren't integers, even though that's what we're using. It's because Antler has an internal class or an internal object called terminal node, and that's at the lowest possible level. And so we'll be using terminal node to identify the values as part of our dynamic and static comparisons. So when it comes to building, this is really how you use Antler. And let me close this or try and minimize that. So if you can see that, we didn't have to write this lexer, this KSQL lexer. We got that for free. And all I'm doing is creating an Antler input stream, which is effectively a wrapper around the string type, passing it into the lexer. I pass the lexer into the parser. And again, I didn't write the KSQL parser. That got generated for free as well. And I have it. Because all I can do now is call the top level expression, the same thing that you saw me do with the tree at the data visualization. And I can go through this expression now and start to fork based on different statement types. So for instance, if it's the select expression, and this is certainly not idiomatic, and this was kind of interesting to go through this experiment, but in Antler you do this, the not equals null. There's no friendly wrapper that you can use. You actually have to do this kind of null assertion that lets you know that this is the correct statement type that you should be going into. So in this case, if it is a select, then we'll go in, we'll set our statement type, we'll set the table, and you'll notice this is the sort of API that Antler provides you for grabbing things like the table name. So we can grab the table name from the select expression. And this is effectively what we do with Antler. There's two ways you could get this information out. I'm manually iterating through the tree. The other option is you can set up a listener. So it's a listener design pattern where effectively you can load the tree up, and as certain nodes are traversed, your system is notified of that. So that way you could build this information up two different approaches for the different programmer in you, I guess. And so finally, there's a bunch of security tests that I cooked up, specifically around testing good statements, testing bad statements. And what I wanted to do was something simple for allowing or not allowing queries. If I look at the secure method, I'm passing in a set of information here. So a list of bad statement types, a set of bad table names, a set of bad column names. Do we want to block on static tautologies? And all I'm doing is just checking values already set in the intelligence structure and then using that as a way to allow or deny. And the security tests over here are pretty straightforward because I created an intelligence structure, and then what I'm able to do is interrogate by calling the secure method on the structure with the statements, with the list of tables, if I want to block on tautologies or not. And so if I go into the root over here, we can run our unit tests to verify that the application is behaving correctly. This will go in and automatically go and compile the ANTLR grammar, and we passed all of our tests. But remember, we implemented delete as something new. So we can go back in and add a new intelligence test specifically for delete. So if I wanted to, I could go in here, public void test delete, string SQL, delete from users. And I will go down here just to save some time. So we're going to build the intelligence object, and now we're going to just check that it is in fact a delete statement. So we'll go back here, we'll rerun clean and tests. So we had 13 tests before, and now we had 14 tests with 0 failures. So again, in just a matter of minutes, we were able to go in, add a new thing to our grammar, code it in, build a unit test, and verify that we're actually collecting this information correctly. So very naive implementation, but it just goes to show you how far you can go with something like a grammar-based approach. Now, there's lots of expansions you can make. Don't think for any minute that KSQL is ready for production or prime time. There's lots of expansions that if you wanted to take a stab at, you totally could. So for instance, if you wanted to support chained exceptions, chained conditions like and or, you could also do mathematical evaluations. And in my particular case, I'm comparing the literal value of terminal nodes. But if you wanted to, you could actually do the evaluation of mathematics or arithmetic if you wanted to. And you could also make optimizations based on your parse, because if your parse tree fundamentally looks the same, and if all you care about is tautologies, then you could short circuit evaluation as well. So lots of micro optimizations you can take. So how is this useful for runtime-based applications? Well, you could do the SQL analysis from within the context of your application. So there are lots of fun ways you could do this. One would be via a runtime approach where you use a library like ASM to load class loaders and to munge class loaders as they're being pulled into the system. So an example would be if I wanted to invoke this langsec security call while statements are right before Java statements execute or SQL statements execute, I could shim java.sql.statement.execute. And what's really novel is you'll then be able to get the language security forensics and visibility combined with the app security visibility combined with the network security visibility. And I'll show you an example of what that log looks like. I think the really cool thing about doing it through the application, though, is that you don't need to unmarshal network packets. You don't need to be a bump in the wire. You don't need to be a proxy-based solution. You could just see the actual query before it actually executes. So in terms of forensics, you can pull out the query, the statement type, table, columns, and all of that metadata is provided by langsec. But what's really cool is you can also pull out things like the number of returned rows. So because you're sitting inside the app, you can now combine all the intelligence coming back from the database plus the actual query itself. You can keep track of where the query executed in your code base too, because if you use something like ASM, you can invoke stack traces. You can figure out where the query is actually executing from the file name down to the line number. So if you wanted to build things like behavioral models or statistical models on top of langsec, you absolutely could. where you could build normative patterns or understand normative behavior based on, let's say, the number of returned rows firing from a particular file name and line number. And finally, on the network side, you're able to pull in all the stuff around the HTTP request, including the high-level URL, other request metadata, so you can compress everything into one payload that could be logged and be really useful for forensics, or after-the-fact investigation could be useful for root cause analysis as well. And when you package it up into an agent, whether it's a Java agent or a .NET DLL, could be a Ruby gem, could be a Python egg, the idea is that you could get this installed during your CI phase. So let's say you're running something like Jenkins in your environment to build your applications. You could add it in as part of your Jenkins pipeline. Or if you're using an orchestration framework like Puppet, Chef, or Ansible, you can go in and attach it directly at runtime when the app is in production or even in a staging environment. And I fundamentally believe that getting this LangSec visibility is great because now you can start to get everything that's happening from a language perspective combined with everything that's happening from an app and network perspective into one payload, which is awesome because as someone who's been a security analyst and done security analyst-like work before, correlation is a nightmare. And I think I see some heads nodding in the room too. So there's a lot of other fun things you can do with a LangSec-based approach. You can do things like data masking, and rather trivially, because if you can break out a database query, a neat thing is you could actually go in and obfuscate the sensitive information. So there could be credit card numbers, could be social security numbers inside your database queries. And if you wanted to mask it, you absolutely could. You could redact information that's going to go into sensitive log files on disk, other web application log files as well. Another interesting approach is you can use LangSec post-mortem. So let's say you have a database query log with a lot of events in there. You can use LangSec to build a histogram of what exactly executed. So you could build kind of a heat map of the different columns being invoked, the different tables where information is being pulled from, the variation of the different statement types you may have, the number of tautologies or dynamic comparisons. And finally, as a data viz junkie, you can also use tools like processing, libcinder, which is in C++. Processing is in Java, libcinder is in C++. D3 is in JavaScript, so you can visualize this information in an arbitrary number of ways. So in terms of the future, LangSec is an emerging area of interest, not only for myself, but for the community at large. Meredith coined the term in 2005, and more than a decade later, there have been a lot of interesting approaches and usages of LangSec. There's an annual IEEE conference, and I can't underestimate how awesome that conference is, and also how relatively academic that conference is. And it's been great to get more practitioners of LangSec going and participating in these conferences, because there is a divide between academia and actual implementations in the wild. Now, I've talked about defense. This example that you saw with KSQL is purely around defense, but you can use LangSec in an offensive way if you wanted to. I've seen plenty of tools recently where people are extending SQL-based attack tools to not just generate queries that contain simple tautologies, but they can generate more complex ones. And if you read in a database schema, you can start to generate more interesting ones based on mathematics, string replacements, string concatenation, the sounds like as well. I've seen those kinds of implementations as well. And again, you can put it into an application, and there's starting to be conversations around applying LangSec at the edge, trying to move it out to the network layer before something even makes its way into the application. And there's numerous ways you can get involved in LangSec too. You can start simply with that code base that I brought up, and that's really a toy, but it gives you a good starting point in terms of it's a Java file, that's one file, it's 2 unit test files, and it's 1 grammar. And that could be your entry point into something like language security. Now, if you wanted to really step up and get involved, the community needs more grammar implementations. So the Antler repository has some grammars that other people have already written. So if you're looking for grammars around regular databases like, let's say, MySQL or Oracle, there's some okay implementations in there. I wouldn't say that they're production ready, but they're an interesting place to start. You can certainly go and contribute more different kinds of grammars, but I really think the big thing that LangSec needs as a community is larger data sets. Remember I started with testing? Remember I showed you all those different test examples? I think the big problem that we have as a LangSec community is that there's just not enough data sets to verify that the grammar or the grammars that are being built are in fact correct. So let's say you wanted to build an implementation for MySQL. It means that you'd have to be able to have a correct grammar of MySQL. And for those that understand, have ever seen the MySQL source code, the lexer and parser are written in C. And it's highly coupled with the existing code base. So trying to extract knowledge out of that is really, really difficult. So ultimately it comes down to the grammar quality as well as data set quality, and one can help reinforce the other. Specifically, if there are more data sets, and if we as a community can organize a Netflix prize-like solution, I think we can go a really long way together. And again, there's a very active mailing list with a very active set of discussions on there. The IEEE conference is just the start. I've had a lot of conversations with a bunch of the organizers, and we think that we're going to be able to set up even more conferences, starting maybe to set up some regional ones in certain areas where more people can get involved and more people can understand how LangSec can be used in the context of applications. So thank you very much. I really appreciated being here. I really enjoyed walking through a live implementation of LangSec, especially in this particular setting. If you have any questions at all, happy to answer them now. We've got some time. I'm also going to be at a booth right around the corner from here, the Brevity booth, and I'll be able to walk through and actually show more people about the grammar as we go later today. So thank you very much.
Using this with something like RDF or NLP to accelerate identification and runtime speed? Are you allowed to tell me that? Do I have to sign an NDA?
No, you don't have to sign it. You don't.
Is that a stupid question? I'm sorry.
No, it's not. It's actually not, and it's not for a couple of reasons.
The lexical analysis reminded me. I've done some semantic web RDF work when I was I wanted to use at one time triples to help identify, to create more fast and frugal responses in terms of identifying threats in traffic, but it looked very similar because it's that uses some lexical analysis, and I wondered if that's what do you partner it with to speed that?
So, fantastic question, and you don't have to sign an NDA for it, and we happy to share. So, the biggest issue you have with SQL, something like SQL injection, is tautologies. So I defined the mathematical use case. Ultimately, and I believe Microsoft has open sourced something really cool around statistical solving, so SAT solving. I think this approach pairs really nicely with SAT solving, because what you can do is you can generate a tree like this and then run a SAT solver around the static or dynamic comparisons to fail very quickly or assess very quickly whether or not something truly is a tautology. And the sort of setup time around SAT solving is an unknown quantity on my behalf. I have not gone or looked at that yet, but from conversations with other folks in the LangSec and research community, we've heard that that might be a really promising thing to pair LangSec with. The other approach is around doing tree optimization, specifically when you're generating the lexical nodes or the parse tree. If the structure of the tree is fundamentally the same as a structure that you've seen before, there's really no need to go through the evaluation or transformational process. So from a very naive way, you can think of it as caching, in terms of, if I've already seen this before, why would I need to look at it again? Yes. 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 So no NDA required for that.
I'm trying to visualize how this fits into your threat defenses. Does this fit into the runtime? It's compiled in with the code so that this is kind of an engine that's being used as it's getting the inputs and comparing. You had mentioned that there used to be thousands of regular expressions. Mm-hmm. This is now the input goes through this quote truth engine or this truth comparison before the actual code takes the query and executes it. Is that how it works?
That's absolutely right.
Okay.
So rather than taking the raw SQL string and running it through the battery of regular expressions, you can now pass it into that intelligence object, or you can create the intelligence object, and then if you wanted to iterate through that, you could then do your evaluation or modification.
So does it mean, I guess I don't understand, that's the question I had. Is it actually embedded in, or is it, okay.
Yes, so there's a couple of ways you could do it. You could programmatically put it into your code base, or as I defined a little bit ago, you could go in and use something like Java agents to shim it in, or you can go through, let's say, popular web application frameworks. For instance, Ruby on Rails has a lot of callbacks that can be used to do this kind of analysis of a database query before it actually leaves the application to a target database engine. And again, the nice thing of being able to do it inside the application is that you don't have to deserialize packets. You don't have to sit or break TLS between the application and the target database. No need for managing certs. You live inside the app, so you actually see the full query before it goes out. And it's not just limited to regular queries. It could be prepared statements as well, because prepared statements alone just aren't also safe. There's lots of ways you can have unsafe usage of prepared statements. So again, you could do this.
So I can understand how this works in a traditional SQL environment. How about if you're using an ORM and you translate into more object type things where the SQL is not really run until oftentimes you don't even see it, right? It's run by some other middleware of infrastructure. And what about NoSQL type things?
Two questions, I'll answer both. So let me go back to this. So that second bullet point in this particular case is specifically an interface. It's actually not a core library. This is an interface that Java defines. And so specifically to the first question, if you're able to shim, and not just this interface, you shim implementations of this interface, that means that gets you the ORM layer for free. So you don't have to design anything specifically for Hibernate or for Spring or any of the other middlewares. You're effectively intercepting calls that implement this method. And it just so happens the things that implement this method are database drivers. And so you're at the lowest common denominator before it leaves the application. And so this is how you do things for SQL. There's a specification. So I believe to be a certified, at least on the Java side, to be a certified SQL driver, you have to implement this interface. And there's a series of interfaces for statements, prepared statements, callable statements. And now for your question on NoSQL, there is no interface. And so to do something like NoSQL, you actually have to do augmentation using something like ASM of the NoSQL driver as it's being loaded. And so a good example of this is, let's say you're using Cassandra or MongoDB. They have relatively non-standard drivers because they're very different and they may handle connections differently. They may send queries differently. But more often than not, there's usually one choke point in all the drivers where you can see in plain text the actual query, whether it gets converted or modified. There's still an ability to see that query before it does get converted or modified into some serialized form to be used on the other side. So before it maybe gets converted into its thrift equivalent, let's say if you're using something like Cassandra, or gets converted into a BSON object if you're using something like MongoDB. Yeah, the deck is available online. And I know from the OWASP, talking to the OWASP organizers, this deck will be available through AppSecUSA, and it's also in my GitHub as well.
Okay, so the second part of my question was, when you're kind of moving from a blind SQL injection back to more sophisticated, like known fields of the table, what, I guess, are some of the ways you describe, like you mentioned offensive, like what is the second part of this that could be used maybe for offensive strategy?
Oh, awesome. So a lot of the SQL offensive tools that I've played with are relatively limited in creating tautologies. They'll only look at the fact that maybe two fields or a field is an integer or a string, and then it'll craft the tautologies of, quote, 1 equals 1. But if you know that something is in fact a string, you could try to craft more advanced tautologies like string replacements, or you could do 2 upper or 2 lower. So if I had a lowercase string, I could say lowercase string equals upper or 2 upper on the same lowercase string, which would effectively get me, if I had an uppercase string equals 2 upper on a lowercase string, I could compare equality between those cases, and that would go by a lot of defenses today. And so from a proactive perspective, being able to generate those kinds of queries would prompt you to sort of level up your level of defenses that you may already have today. All right, thank you everyone for coming. Really appreciate it.